Door close ಮಾಡ್ಕೊಂಡು ಹೋಗು.
Welcome to Dr. K. Swami. Please start.
Very good afternoon. Thanks for your session, sir. This session is going to be in the morning session. We have learned about the machine learning and IoT, the features of IoT, then how to embed IoT in the machine learning, and these kind what are the applications in detail. We are in a 2-hour session. We have learned that. I think all the participants have satisfied with the theory session what we have had in the morning hours. Continuation with this, this session is going to be explained about the Internet of Things with machine learning and how it is going to be enabled, the IoT in the machine learning, and also some demo which is already done by our students. That is going to be given detailed demonstration in this session. So this machine learning techniques are going to be very systematically embedded in the IoT applications. That is going to be explained by my research scholar and my friend Dr. Gurraj KS. He is associate professor in the department of CSE, GCSS Institute of Engineering and Technology for Women, Mysore. He is working in this area from past many years, and he is very well expertise in the Internet of Things and machine learning, and he has done his research work also in this area. So I welcome Dr. Gurraj to take over the dais.
Thank you, sir. Thanks a lot, sir.
Thank you, Gurraj. Dr. Gurraj, sir. Welcome to SITAMS Engineering College, Computer Science Department. So I have made you as a focus, sir. So
yes,
you can share the contents anytime.
Okay, sir.
Thank you, sir.
Can I start, sir? Am I audible?
Yeah, audible, sir. Yes.
Okay, sir. Okay. Thank you, sir. So let us start with the afternoon session. And first of all, before starting this session, I'd like to thank Srinivasa Institute of Technology and Management, Chittoor, and Dr. Thippeswamy, sir, for giving me this opportunity to present some of the works carried out over here and some of the things that I know about Internet of Things and machine learning from the perspective of practical aspects. It would have been better if we had a face-to-face session so that we could have demonstrated. But as it's an online session, we try to present some of the works carried out over here. Okay, so let us start with the session. So the session we move on to the session that is Internet of Things and machine learning from the perspective of practical aspects. So to move ahead with the agenda of my presentation will be like what actually, even morning session we had already discussed about the machine learning, the basics of machine learning, the Internet of Things, and how they are interrelated, and some of the applications over there. Dr. Thippeswamy sir has explained in detail about all those aspects. So to start with these aspects, let us, I'll be just trying to give an overview of these things, and then I'll move ahead with certain IoT aspects. So here my presentation will be basically oriented on IoT, that is Internet of Things, and how it will be coordinated with respect to the AI, and what are the life cycle, how this IoT applications, we work with machine learning, what are the aspects that we deal with when we work on IoT related to either artificial intelligence or with respect to the, either it may be with respect to machine learning, right? We'll try to see how they are interrelated, how they go about together, and we see some demonstrations of those applications. And we'll be seeing about basically this session involves about description about IoT components, how these components are there, what are those components, how do we interface those components, and programming can be done with respect to those components, right? All those aspects we'll be discussing, and we'll be discussing about the IDEs that we can use, and we'll be seeing the Arduino as one of the aspects over here. Arduino IDE and the program structure, how we work with that, and the we'll be seeing one or two case studies of IoT applications that we have designed in our lab over here. So to start, let me start with the session. These are the overall agenda that I have. So to start with an introduction part of what actually an IoT is all about. So Internet of Things is nothing but the aspects where we deal with whatever the modern day tools that we see. It may be mobile, it may be cars, it may be a computing system, or it may be a chocolate vending machine, or anything that we see on a day-to-day basis. It may be a simple weight monitoring system. We see that all these applications are one or the other way related to each other through certain sensors or certain informations that we store somewhere, and we try to process that informations, and we try to analyze those informations and try to have a meaningful correlation among those, and try to have some decisions that has to be made. We may go to a supermarket and we see that all items are interrelated over there, how they are they are arranged, and based on their arrangement there'll be the sales perspective. We'll see how they are going to be going through. So all these machine learning algorithms and data mining algorithms and artificial intelligence all are interrelated in one or the other way in our day-to-day life. So we see this machine learning. So machine learning is nothing but a predictive capability. It provides us certain analysis. It provides us to make our machines to predict, to analyze, to see how these integrated platforms work together, and how this data can be stored at some location, and how those data can be analyzed by. It's not that we in earlier days it is what like we used to give data only through the voice, or it may be through your keyboards, or it may be through your any other input devices. But now sensors have, when IoT has come into existence, sensors have made a big impact on our day-to-day life. And we see this IoT platform will provide us an opportunity to retrieve this data, like it may be temperature, it may be moisture, it may be the alcohol sensors that we have. We can see our police holding those guns where the alcohol sensors are available, which gives us whether the person is drunk or not. All those any device that we come across. Temperature sensors, nowadays we see in our day-to-day life everyone carrying the temperature sensor to see the temperature. So we fetch the data and try to store into different IoT platform storage locations like Microsoft Azure IoT, or Amazon AWS IoT, or Google IoT for edges. So there are various platforms that we have where we can store this data. And all this, if you see that machine learning, these applications that we come across, all this cloud environment, and all these are where we store the data. This Arduino, Microsoft Azure, Python, AWS, Raspberry Pi, they're all the IoT platforms from where we can get the data. And it acts as an interface between our inputs that we give, and where we store, and how do we process the data. All those aspects can be carried out through this particular interfaces that we come across. So for example, if a sensor detects an excessive heat or vibration, it triggers an alert. Just like I have a mobile where if I change the direction of the mobile, I can see that some application being running. If I vibrate that mobile, some activity be going on. So there are various sensors in our mobile devices that we use on a day-to-day basis also. So this, if I change my direction, nowadays you might have seen that these online tests are conducted based on AI-enabled and IoT-enabled devices, where if a person turns his head in one or the other direction, we could find that the person is doing something over there. We can monitor the person somewhere else, how they are able to, because of this AI sensors that we have in our devices, they're able to track us what we are doing. If the same sensor is connected to internet, they can the data can be collected from those data, and try to fetch those data and try to analyze the data using some machine learning algorithms or the data mining algorithms, and see what best can we do from that data. How we can just see what are the probable aspects that we can take decision upon, so that we can enhance the efficiency of the systems or efficiency of the applications that we are running. So all these Internet of Things plays a vital role in our day-to-day life. So what actually is an IoT? It's nothing but a connected device. Every connected device, it may be a sensor, it may be a voice recording system, it may be a moisture sensors, or it may be any device that are interconnected with each other. All those devices are considered as a thing, right? The Internet of Things instance, all these things that are one or the other way, they are related to each other, they are interconnected to each other, and all those devices are called as things, and all those are connected through internet, hence we call them as Internet of Things. And so these things can be either physical sensors, or it may be actuators, or it may be embedded microprocessors or microcontrollers, any component that we can interconnect through certain medium of communication or medium of interface that we can design. And when we try to get the data from them, so these things needs to communicate, as in morning session sir was talking about machine to machine communication through either it may be Bluetooth, or it may be, now we have our health bands where our health data is monitored using Bluetooth communication. We have our headsets where we need not communicate, our mobiles are communicating through these headsets using some communication medium. So Bluetooth device that we use, earpiece, is again a device. Our mobiles are on a device. We are not interfering anywhere over there, but they are able to communicate with each other. So the devices, machine to machine communications, are able to do that. So how do we handle this? How do we handle this huge amount of data that we are trying to fetch them? We get from those devices, and how to process that, and how to get some meaningful information, coordinated information from those, so that we can utilize it for enhancing the efficiency of the systems that we are working, is a very, very important aspect that we need to focus upon. And machine learning and AI based applications support us in doing all those things by collecting. So this IoT infrastructures provide us an approach to handle, store, and analyze all this data, which we are storing at some location. That may be either a cloud environment, or it may be stored on a particular computing device. So taking all those data into consideration, we need to have cloud. We have this cloud servers. From there, we try to fetch those data and try to do various machine learning techniques, which we can use for analysis of those data. It may be analyzing what is that happens. Let us assume that how the person's health is dependent on the air quality of particular environment. It may be like monitoring how the pulse rate is will define what is that he may be doing at the next moment of time, how the emotions are being controlled. So I can have a EEG device and try to monitor the emotional aspects of a person. So I have that's again an IoT device that we have to monitor. So all these are the modern application devices that we have where we can use and coordinate with each other. So IoT and AI, they are go hand in hand. So IoT, AI, machine learning, big data analytics, all these play an important role. If you can see this diagram over here, all are interrelated. So AI and machine learning decides what we have to do, what is that we can carry out. IoT devices are the components, they sense what is the input that we can get from the surrounding environments. We can fetch all those data through this input IoT devices, and they can fetch all this data that is collected can be stored at certain location, and store it as a cloud-based data, and they save your data. Taking those data based on a timely analysis, we can train the AI and machine learning algorithms so that we can decide what is best for us, what is the best efficient systems that we can design. So all these three have to be coordinated one or the other way to have a better applications, a more successful implementation of those applications. All these three, if you can see here, all these like cloud has data centers. There are thousands of cloud data centers that we have, because a huge amount of data is being generated. Every second we have a huge amount of data that is being generated somewhere or the other. I store it on data centers or the cloud. I have these nodes where there are millions and millions of nodes which are interacting with these edge devices. That is nothing but our IoT device. There are millions of edge devices that we have. Well, what we use in our laboratories on a day-to-day basis are very few. But if you see on a day-to-day basis, there are n number of devices, billions of devices, edge devices, which fetches us data, which we can use it. Huge in petabytes of data can be generated, and these edge nodes, intermediate nodes, they communicate data centers to store that. All these three, IoT, or then the which for us, we can consider it as a input and output devices where we work with in a normal computing environment. We can consider big data as a storage devices where you can store huge amount of data. Using that data, we can have n number of algorithms, AI and machine learning algorithms, which we can train to take particular decisions or to make our system more efficient. So this way, all these AI and machine learning environments are interrelated, and the coordination between all these three are is very essential in order to have expected results or the successful implementation of any applications that we come across. So the IoT lifecycle, as morning sir has already explained this, I'll not go in depth about it. So how the machine learning algorithms and AI algorithms fetch the data, pre-processing of the data, all these are taken care. Like we have to model and deploy using certain machine learning algorithms, and then we need to have models for generation. And once we have this data generated through various sensors, we can have the reports generated through the algorithm, AI and machine learning algorithms, through the data that we have received through these IoT sensors. And we need to process that, the data that we receive, as in the morning session, sir told that data needs to be pre-processed. All this, the life cycle involves all these aspects. IoT data analytics involves all the aspects that were discussed in the morning session. And taking all this data, we try to analyze and we provide the reports or the decisions that are being done through the AI algorithms or the machine learning algorithms on this data that we have fetched through one or the other IoT-based sensor devices. So once we have this IoT life cycle, so an AI-powered capabilities, IoT data that can be transformed, analyzed, visualized, and embedded across the entire ecosystem provides us an environment which we can use it for the betterment of the society. That is, if we are using all these aspects in a very good and efficient manner, try to analyze those data that we have fetched, that gives us the results which we can use it for the betterment of the systems that we are using on a day-to-day basis. So how this AI and IoT and machine learning are interrelated together. So IoT sensors are added. We have various IoT sensors that are added to the machinery, just like monitoring your discrete variables like vibrations, noise, heat, temperature. If I'm talking now, I can just measure what is the vibrations of my voice, what is the frequency of my voice, how loud I am, how fast I'm talking. Anything that can be discrete variables can be measured by using the different sensors that I have here. And once we have those data that we have, we can upload those data onto the cloud for using it for carrying out the analysis by using various algorithms. And this machine learning sits as a model sits as on the cloud platform for feeding the input data. We have the input data through all these IoT sensors. Once we have this data stored on the cloud, the machine learning algorithms and the AI algorithms play a vital role to fetch this data that is stored in the cloud environment and then try to analyze those using various algorithms. We have this like clustering algorithms, we have classification algorithms, then we have n number of neural KNN algorithms, we have the various neural network algorithms, we have n number of algorithms we have which we can utilize in order to. So once we have this data, we can split the data and try to convert them into training data and testing data set. And once we train the AI systems to see that they work as per our requirements and try to analyze whether they are working as per requirements, and we can verify our data whether it is useful for us. How can we see? So there can be thousands of records. We have to try to correlate those, try to project and define an hypothesis and try to prove that this hypothesis, whatever hypothesis is nothing but some assumption or something that we feel, yes, this is going to work as per my analysis. This hypothesis, once we have the hypothesis, we need to try to prove that the hypothesis is working fine by taking all these machine learning and AI algorithms so that from the data that is fetched from these sensors. So once the hypothesis is created, it has to be tested and validated by using the data set. We have to use those training data sets. Once at the real time, if we get those training data, real-time data, it should be able to analyze as per the training data set that we have trained, and we should get the results as per our expectations. And once it is done, we have an executable endpoint for the application, which we can use it for our analysis, where we can say that if a person is having so-and-so pulse rate, he is bound to have so-and-so disease. So like we have diabetes, if sugar level, all these are at a particular levels, he is bound to have certain issues in the future life. So likewise, we can trained model can analyze and give us certain inferences based on the data that we have, and we can see that whatever we are expecting, whether it is being able to achieve, right? We can just try to get that and go through the data, we can analyze and get. So what machine learning does? So with IoT devices that are connected, they communicate with each other, collect enormous amount of data, as I was telling earlier. We get all those data through the different sensors. And once we get that data, not only that we collect the data, these communication devices also are autonomous. They can function on their own without any human interferences. As I told an example of our mobile and the headsets that we have, which can communicate with each other without any human interface communication, and then they can collect the data. Once we have that, we can get collected data can be try to make it as a context based decisions. Once we have those decisions, we can say what best we can analyze. So based on all these requirements that we are generated, we have come across an IoT called as cognitive IoT. Cognitive IoT in the sense, based on our activities, what is that we what decisions we can take, like as I told, a health band based on the different activities, running activity, based on skipping activities that I do. It gives me the various data, how my heart rate is, how is my pulse rate, what is the oxygen level, oxygen saturation level that I have. All this, based on that, I can analyze what is the health condition of a particular person. So deploying all those, how does it analyze based on the data that I have and the IoT infrastructure that I have? It has we have various applications that are designed based on, in earlier days, only input devices that we had is a keyboard and mouse and everything. And we had algorithms and programming aspects involved in with only the data that we used to fetch from that. But nowadays, the algorithms of the programming environments that we have, if they work on only those data, it doesn't suffice our requirements. So we need to have more and more applications, more and more interfaces, and more and more infrastructure has to be enhanced so that our applications become more which can be utilized. So machine can be used for like network optimizations, congestion avoidance, resolution allocations, and various real-time and offline data analysis and decision makings based on all those data. You can now, whenever I want to know how many people visited a particular mall on a particular day, there's no need of anyone to keep a person to stand over there and keep counting nowadays. You can have a sensor which have an infrared sensor over there. It blocks the road. Once a person enters, it cuts that particular infrared ray, and the counter will be incremented. So as and when you the increment, so you have two different ways of entry and exit. So as and when the person enters, the counter increases. At the end of the day, you can just check what is the counter value. You know how many people entered. And if there are repeated entries, again, there's again a flaw over there, which we need to take care of in such scenarios. So this machine learning, if you see this diagram over here, once we have a problem in our hand, we should check whether is it a machine learning task, whether we can carry out a machine learning task through the data that we receive through those IoT devices. If it is no, then we have to find an alternate way to solve that particular problem. If it is a correct and if it is a machine learning for digital data, or I get the temperature in terms of analog data, or what is the source of information that I'm getting through these sensors. Once I get, what are the proper evaluation matrices that I have. So suppose I want to know, nowadays we have vehicles where we have sensors. I want to know how close another vehicle is to my vehicle. So how do I measure the metrics? So I need to have the distance. Do the sensors provide me a metrics to measure the distance? So how do I measure? We'll see that in the next part of my deliberation. I'll just go through that, how these sensors, that this sensor measures the distance. So once we have the data, we have the sufficient data, if at all there. And if I have sufficient data, whether it is pre-processed data, whether I can analyze the data based on whatever the format it is available, which is unstructured or structured. And based on that, what is the model that I try to make? If I'm using one particular analysis model, does it complicate my system? If it is a very simple application, if I take a complicated model like neural networks, then it tries to complicate my application. So I have to decide on those. And if I carry out, what are the engineering features? Now I have it in terms of, as I told, distance is what I require, but the sensors does not provide me distance. Instead, it provides something else. So what it gives in the form of a time parameter. How do I measure distance from the perspective of time? So how do I convert it? So once I get it, what are the evaluation sets? How do I evaluate that system that it is accurate? So all those enhancements we have to try to see whenever we are trying to implement this machine learning through the data that we get through IoT devices. So if you can see over here that machine learning with IoT devices we have, they store it into the cloud data. And based on that, we have AI and machine learning algorithms. Once we have these algorithms, we try to have a decision-making system or some application which becomes an innovation. So we have very huge amount of data that is being exploded in terms of a zettabyte of data that is being generated at present through various point of sales, ERP systems, content resource management systems, then our social media networks, we have ERP systems. A huge amount of data is generated. Take that data. How do we get the data? From various mobile devices? Then we have sensors, we have computing environments, right? And all these are connected to each other through one or the other medium like Bluetooth, Wi-Fi. We have wired connections and all those. So once we get this data from all these sources that are connected to each other, this is what we call as a twinning world. What the sensors see, and we try to map it onto our real-time world, right? We try to see that the IoT and the sensors, whatever the data that are fetching, we are trying to relate it to our normal day-to-day life, how a human being comes across, how we can use it for a human being, day-to-day activities of the human being. That is, we are trying to twin between the digital life to a normal human life. And once we are able to twin it between the automation systems and the existing business process or the human activities, then we have achieved our goal. Inventing new business models or solutions or the products by twinning the digital data that we get into the activities that we do on a day-to-day basis. If we are able to do that, like satellite data that we are getting on our GPS, we are getting the data into digital data. We try to map it onto a graphical device on our mobile devices. We have a graphical image, and we try to have a vehicle moving based on the sensor. We have a GPS device, which it's again a sensor. Based on how this GPS sensor moves, we are trying to map it onto the graphical device and see where the person is, where what is the distance. We try to measure the distance. All those activities, we are trying to have digital data mapped onto our regular activities. So what is the advantage of having this machine learning and IoT and the AI interrelated, and we get applications? It simplifies our models, what we work with, flexibility of using our data of our choice. We can use it as per our requirements, rapid model deployments to operationalize machine learnings quickly. We can train the machines and we can make decisions better. Pre-built connectors for operational and historical data. We can store huge amount of data if it is required. Then we can, what is that we are trying to achieve in the modern day is that we are trying to integrate IoT with AI and machine learning and streaming of those data and trying to analyze all those data. So when with all these discussions, we could find that IoT, AI, machine learning, all these are very important, and they need to coordinate with each other, and they have to work with each other. They have to work in coordination so that we can get better applications over here. So with all this background, let us see what are the applications that we have. So if we see on a day-to-day basis, every activity that we are involved in are having one or the other AI-based activities or the machine learning-based, like smart homes, wearables, as I told, the wearable jackets where we can have sensors. I'll show one jacket as an example in my demonstrations. Then we have smart cities, smart grids, industrial internet facilities, connected cars where we can check out the distance between two cars and all those, the healthcare monitoring system, retail systems, where we have sensors to see whether a person is carrying any item out of the shop. By just having a sensor, we can see whether he's purchased and carrying it out. Without purchasing, he's carrying it out of the, we have sensors at the exit. And if there is a beep sound, if there is any interconnectivity between those sensors, it gives a beep sound and automatically we can say that he's carrying without billing. So supply chain management, smart farming, there are various applications. So all these that I could put into one real-time world. If you can see, there's no activity, fire management, then shipment conditions, where the ship is available, water quality monitoring, then golfers, what is the length of the grass that we have at the golf course ground. We can just smart parking systems, waste management. Then we have item locations where in shops. Then automobile industry, water leakage system. A morning sir was talking about this water leakage systems and how to pump the water from tank on the overhead tanks, right? All these applications we can see. We have electromagnetic levels, traffic congestions. We had one question in the morning session regarding the monitoring of the traffic congestions. And we could see nowadays we find that whenever there is a traffic light, we see the people trying to rush towards the signals and cross the signals at the faster pace when we have green signal. So there are applications in that I could monitor when I had been to US. I could find that there the application could sense if there are any other person who is trying to approach that particular signal, and based on the sensing of any object, it could still maintain it as green. Once it finds that at a certain distance there are no objects, it used to turn it into red color. So in India, I don't know whether we have it at present. So we can use those applications to see that there are minimizing of accidents. Smartphones are a day-to-day part of our life. Then we can have radiation levels in the furnace monitoring systems. All this, we have air pollution controlling and wine quality monitoring. So there are various. We have sportsman care, like in cricket we see the sensors where we can identify whether there's sneakometers which will give whether there is edge or not. So various applications have come on a day-to-day basis where we can use this IoT. So let us see how these components are gone with respect to IoT. So the edge intelligence systems, we have a smart IoT system comprises of some components like mechanical and electrical parts. It was discussed in the morning session already. Sensors, processors, storage, and the softwares. Then the ports, antennas, and the protocols that we have, communication protocols. The onboard analytics for training and running AI models. So all these components, you can see the machine learning aspects. If we see the first ML1, it can be applied at an IoT nodes using the IoT device resources. I can collect data from different locations by using this IoT resources. Data collection is one important part. Hello. Can I continue? I don't know. Sir, am I audible?
Audible, sir.
Okay, fine.
Sir, I will take care.
Okay, so fine. Because I am finding it here that there's some disconnection. Okay, fine. So thank you. Thank you for the information. So we have ML2, that is machine learning can be applied for fog nodes, where we can have more computationally intense nodes for analyzing the data in the network edges, how they are communicated. Then we have big data storage analysis, how we are getting the cloud nodes, what is the frequency of the data, from which data centers we are getting the data, and how frequently we are sharing the data, from which particular devices is the more data available for us. So all those data can be analyzed. The other applications like smart city, where we can analyze the use of collected information like waste management, smart homes, like we are morning server saying that security of the house, when with a particular device, if you enter the home, you are allowed to enter into the home. If not, you are not. If a person without a device and a device without a person, it doesn't make any sense to enter. It doesn't allow you to enter into the house. So all such applications we come across where we can use the IoT platform. Is again, as I told, it's a platform where we can fetch the data, we can communicate the data, we can have different devices for different category of people, like a person who is physically disabled with voice, he can be given with a different IoT device. A person who is disabled with sensors they can be 5 different n number of sensors we have. If any person is disabled with a particular sense, he can be activated with using the few days back I could see one person carrying a portable heart, just a pumping machine, and without heart the person is alive, with having all these IoT devices, the pumping devices and everything. So all these nodes will has made our life more innovative, more applications, and more flexible, and more user friendly for us that we can work upon. So what are these edge devices? So let us go. These are all with the background of all this, how we can have IoT, ML and AI together, and the cloud environment together. We see how the things go ahead. So we find on a day-to-day basis, we have different senses, and a human being has a maximum 5 senses: hearing, sight that we can see, touch, taste, smell. With these 5 senses, we are able to do our day-to-day activities. And we have sensors at present which almost provides all these sense activities through the machines. We have temperature sensors, we have rain sensors, we have heartbeat sensors, we have IR sensors for transmission and reception. Then we have touch sensors, our mobile touch devices. Then humidity sensors. We have the photo sensors, the photo light sensors, the gyroscope to identify the direction of the device, which east west direction is moving. Then we have, so I'll show you all these devices that we have at our lab, and we use all these devices at our lab. Ultrasonic sonic sensors. I told I want to measure the distance between two vehicles. I can use this ultrasonic sensors for that. The proximity sensors we have in our mobile devices. We have these proximity sensors. If I take this mobile device to my ears, automatically the light switches off. So likewise, we have the gas sensors, which we can use it in our house for sensing the gas. Alcohol sensors, which is a day-to-day activity where police carry this for monitoring if there is any person who has drunken driving cases. Then we have water flow sensors, water level sensors, which we can use in our water tanks to switch off the device as and when it reaches certain levels. So we have all these sensors are the key components of an IoT environment. Without these sensors, you see that there are n number of sensors which are providing the activities that we do on a day-to-day life using only the 5 sensors. We have only 5 sensors a human has, which is being provided to us by using n number of sensors that we have. There are billions of sensors that we have at present. Using those sensors, we are trying to emulate the activities that we do on a day-to-day basis. Vision, we have a camera. For hearing, we have hearing sensors, hearing aids, we have touch sensors. You can find here the touch sensors. We can have taste sensors, then smell sensors, the gas and all those comes under the smell sensors. We can use all those devices. And here I wanted to show this image. The key component that we see here, the thing that we need to observe here is it's just a honeybee on which a sensor is there. That reflects how minute the sensors can be designed. The sensors are designed in such a minute size that it can be placed on a honeybee. It's not just it's a huge device. You can place it on a very small, minute insect so that it can be monitored. And that is how the design of the sensors are in the modern day, so that we can utilize them and we can make our devices as compact as possible so that we can carry. In morning session, sir was talking anywhere, anytime, we need these IoT devices. IoT provides us this capability of having the any day, anytime, at any location services. So even I want it at a minute place, yes, I can place it. That's what I just wanted to project by using this image over here. So let us move on to the practical applications, how we use it into our labs on a day-to-day basis, how we are doing that in our labs, what these softwares that we are using, what are the IDEs that we are using to work on this IoT as well as machine learning algorithms. So to start with, let us talk with the environment which we work on. So the environment that we have is like we need these 4 parameters whenever we want to start working with any IoT based environment. That is operating system, the coding languages, the IDE, and the editors. So we have 3 different platforms that we are working in our labs. That is, one is the Raspberry Pi, the other one is Arduino, and we started working on LoRa from this particular academic year. So I could not include it in my slides for LoRa because I could not go ahead with exploring those LoRa aspects. So Raspberry Pi, we need an operating system called as Raspbian or a NOOPS operating system. The same when we work with Arduino, we don't have a specific operating system here. Instead, we have an inbuilt board-based libraries, board-specific libraries, whichever the board that we are using there. I'll just come to in the next slides. I'll show you what are the different Arduino boards that we had. For every specific board that we have a specific libraries which we can work on. And the coding languages are like we can use either Python or C or C++ or Ruby. And in our labs, we are using Python for working. For certain environments, we use Python. And whenever we have digital-based data, we work on Python. And when we work on Arduino, we have Arduino as well as C and C++ environment. We work the programming languages. Arduino, as I told, it has libraries, board-specific libraries, which we'll be using. And IDEs, Raspberry Pi has its own IDE and the console, which we work on. Similarly, Arduino has its own IDE. I'll be showing the IDE also over here. Then the editors, we can use any text editor. As far as Raspberry Pi is concerned, we can use a Notepad or any of the basic editors we can use over here. And here we have an Arduino editor for working with. So based on what type of platforms that we work, the IoT programming depends. There are different locations or the services on which we work. Like if you are working on end devices, edge devices like processors and all those and the sensors and which we want to program, then C has the highest priority to work with. Either I can use C or C++ if I have told here that coding language depends on where I am working with and which particular components that I'm trying to work with. Either I use C or C++ or Python. As I already told, Python will be based on whenever I have digital data, most of the times I prefer to use Python. And Java is the least preferred language when I'm working with the devices. So C and C++ provides more flexibility for me when I work with these end devices. When I work with the gateway devices, that is the network communication devices, in such scenarios, Java and Python plays a vital role, and they give me more flexibility for communication programming, like it may be socket programming, any device that I'm working with. And C and C++ will be the least choice that we use. When we work with the cloud environment, because we need to store the data that we fetch through these IoT devices, there also we need to have cloud programming that we need to do. And then we use either Java or JavaScripts or Python or PHP. Most of us have done with Python and PHP whenever the cloud programming has to be done. We have worked with PHP and Python for cloud environment programming. So these are some of the environments where we can we have to configure, we have to be well versed before we work on this IoT and machine learning or AI based environments. So once we have these devices, the sensors fetch the data and everything. Once the data is fetched, we need to store them and we need to have connectivity or some way of interface to go through. So what are these interfaces? How do we communicate? The communication devices again are very important aspects. So we have different communication, short range Bluetooth devices we have. Then we have LoRa devices. We are, as I told, now we have LoRa devices which we are working on, which we still need to explore on that. Then we have cellular devices, work with our mobile devices, communication through cellular devices. Then we have Wi-Fi and Bluetooth communications for short range. So 10 to 100 meters when we use this Wi-Fi and Bluetooth communications. And the baud rate is in terms of bytes per second, bits per second to megabits per second, we have the data baud rate available for communication. And we went to, when we want to have a long range communication, we go with the LoRa communication, or we have the cellular communication. We have applications where we can communicate through mobile devices. Also, situations we have used this cellular 4G communication purpose in terms of 1 to 10 kilometers. We have designed applications for such based on where I am using, the scale, the connectivity that we have, the things that we have. So we have sensors over here. We have the Arduino boards over here and Raspberry Pi devices. These have to communicate with this cloud environment. The scale of communication, the distance of communication, and how frequently we want to communicate, and what is the data size that I need to communicate. And if I'm deploying any application onto the cloud, then what is that, how do I communicate? So we have different modes of communication, like based on the baud rate and the distance of communication, the frequency of communication, and where I store, how much of data has to be communicated. So the scale, the data scale, size, and the deployment, how I am deploying, whether it is through Arduino or LoRa communication. So what applications I am designing. So whether I use Wi-Fi communication or Bluetooth communication. For short range services, we can use Bluetooth and Wi-Fi communications. And all these define the way I select the communication. So we selected, the first part that we selected is the operating system and the environment. Second part of our implementation or the deployment of an IoT based applications is selection of the connectivity. So we had to select the connectivity based on all these factors that I just described about. So coming to the devices there. So we go ahead with the devices. So I think, am I able to, or if you're able to see this device that I'm holding, if anyone can respond to me. Are you able to see the device that I'm holding it on my hand? So this is the Arduino device, Arduino board that, so I'll just describe, this is the Arduino board. This Arduino, this is where it looks very small, which I have elaborated over here. So this Arduino board is the one which we started working with. For initial practice, we started working on this Arduino board. And based on this Arduino board gives us an IoT communication platform where we have this Arduino board, which has various components. If you can see this, I'll just give a brief idea of what this Arduino board consists of. So this complete board is categorized into 4 parts. One is the power supply for the device, power supply for the components that I connect, and the analog pins. For whenever I want to have an analog signals to be communicated to the device, I have analog pins over here. That is 0, 1, 2, 3. That is pin number A0, A1, A2, A3, A4, and A5. These are the analog pins. And for the components, if I want to supply the power supply, then I have the power supply for pins over here, the reset and 3.3 volt pin, 5 volt pin, the ground, 2 ground pins based on what I connect, 3.3 volts or 5 volts. Then the input voltage for this, the power supply for the devices. And I have the interrupt pins whenever I want to have this digital data communication I want to have in the form of pulse width modulated data set. If I want to fetch the digital data, I can fetch it from these digital data pins over here. If I want to have a communication devices, I can use 0 and 1. The receiver will be, the transmitter will be 1 and the receiver will be 0. Similarly, I can have interrupt devices based on command interrupt that I generate. I can have the signal generated over here through 2 and 3. Whenever I have a digital data, I can communicate this. So whenever I want to connect multiple devices over here, I want to have a multiple this Arduino has to act as a slave or a master. Then when I want to have a interleaved devices, I can connect through this devices like master and slave outputs that we can communicate, the slave select that we can do. And for those devices, I need to have a clock signals that has to be generated. These pins will allow me to generate those signals. Similarly, I have a serial clocks pulse generator. This particular device is again just like a computing microprocessor. I need to have clock signals generated for this device, just like CPU needs that. These clock signals are generated, serial clock and serial data signals. Whenever I want, I can generate this. Whenever I want to have a USB interface connection, I can use this. So the total system is connected using this male center positive connector. This is the power supply that we use. And to connect to the computer, we have an USB connector. That is USB port to the computer, which will be connected. And we have a 16 gigahertz crystal clock cycle generator over here. This is a microcontroller, Atmega 328 microcontroller. And all the programming that I do is stored. I think all of you are able to see my mouse pointer that I'm trying to move over here. So this is a microcontroller. All the programming that I do has to be stored in this microcontroller flash memory. The size of this flash memory is around 4 MB. Based on what type of Arduino board that I'm using, the size of this flash memory and the configurations. What I'm showing you is a Arduino Uno board. The board that I'm trying to reflect over here is the Arduino Uno board that I'm trying to communicate over here. So the interface for that, just a USB cable we have, and it is communicated to this Arduino board. And all these devices, any Arduino programming based IoT programming that I need to do has to be done using these boards, that is Arduino board. And there are, as I told in the earlier slides, that these devices will have a specific code, specific applications will be there. You can use those specific codes for whenever we are working with those devices. So this is how it works. Let us see how this programming part will be done. So this is Arduino 1.85 Arduino editor. I told IDE is Arduino IDE is available. So using this IDE, we need not go for any normal editor. Whenever we are working with Arduino, we need to use this Arduino editor where we can work on. So this application here, tools that we can use. So the Arduino board that I'm using there, if you can see here, the board manager, the N number of boards listed over here. Some of them are listed. So in this, what the board that I have shown at present is Arduino Uno board we had here. Arduino, this micro board we have, Arduino genuine micro board that we have at present, we are using. You have to select. So here the board selected is Adafruit Feather ESP8266. But the one that I showed was the microcontroller in the earlier slide that I showed. Sorry. ATmega 328 microcontroller IC that we have. That is based on the device that I have, I can select the Arduino board that I am working with. Whichever the device that I have with the Arduino board that I have to select the particular Arduino board. Then I have to set the flash size. Again, when we purchase this Arduino board, it will be specifying us with what is the flash size. I have to set that flash size. Then the ports, whether it has to be enabled or disabled. Then the frequency of the clock cycle. Once we select this board, automatically these are configured by itself, and we can use the Arduino board for that communication. So this is the general syntax for any program that we write using this Arduino board, Arduino programs. The general syntax is we have to, this consists of two basic parts. One is the setup part, the other one is the programming part. Setup part gives you how I configure each pins, right? How I configure each of the, initialize all those Arduino pins that we had. We need to configure those devices, all the pin, which one is the input pin, which is the output pin, and what is the device that I'm trying to communicate. All these pins have to be initialized. That will be done at the setup module, setup part of this Arduino program. And the other one is called as a void loop program. Here the loop program gives me what I have to do. What is that I need to fetch? What is the program? Just like a C program, whatever the program that we write, we have all the executable statements. Just C program, if you see, the declaration part and everything will be at the beginning. And later on, we have all the executable statements. Similarly here, the Arduino program has two components. One is just, we can consider it as a declaration, where we initialize all the pins which we are working with, which is the input pin, which is the output pin, LED built-in output that we are using. All these has to be configured in the setup part. And all the executable codes has to be how I need to communicate, whether what is that I need to fetch, from which pin I am trying to fetch, right? All those have to be set up in this loop. This is called as a loop part because all the code that we specify here, it keeps on executing till you close the program. Till you exit the program, this keeps on looping. There's nothing like termination as such. In C program, we have termination. Here, there's no termination as such. Unless you close the program, it keeps on repeating that process. And whatever the instructions that you are given, that's why we call it as a loop part. So setup part gives us the way we configure our device. Loop part gives us how we fetch the data and how do we get the data from those devices. So coming to a simple program, just I want to go through before we go with the demonstrations. Let me give a simple program where the external LED blinking has to be done. I have an LED, just let me show the configuration. This is the Arduino board that I have, and I have an LED over here. I want to see that this LED should be blinking, that is switched on and off continuously. So what is that I am doing? This is, I have the digital signal that I am trying to communicate. So I'm using this pin over here. So I have connected to the breadboard, this LED, and I have a capacitor to see that the power supply is monitored properly. And I have one of the pins of this LED connected to the ground, and another pin that is connected to 8. That is the port number, the pin number 8. This is through the capacitor. If I directly connect, the LED might, the power supply may be more and LED might go in a damaged mode. So what I have done is I had to reduce this. I have a capacitor to reduce resistor over here to minimize the power flow. And I have connected through these pins, and this pin is connected to the pin number 8 of the Arduino board. So let me try to program this. So the program looks like, so setup. So what is that I'm trying to set up here? Only one configuration that I'm doing, that 8 is used as an output mode, output pin. So output pin is the 8, and I have a loop. That is the loop gives me the instructions that I need to execute continuously for making this output from this particular Arduino board. So void loop. So digital write. So I have used digital pins over here. That's the reason I'm giving it as digital write. 8, pin number 8 with high. When I send high, this LED turns on. So then there will be a delay for a certain amount of time. So to make it 1 second, we have calculated the delay. Based on that, we are given that the delay, it is nothing but a continuous loop which will be repeated continuously for 1,000 times, so that I can view this. Once it is delay is over, again I digital write 8, low, so it will be switched off. So again a delay. So this continuously repeats, so that this LED that is on the breadboard continuously switches on and switches off. That is the blinking of the LED continuously goes through. So if I want to terminate this, I have to close this program. That's the only way that we can terminate this program, and this, because it's in a loop, it continuously repeats, the LED keeps on blinking. It's not mandatory that I have to connect to 8 pin number 8. Any of the digital pins that I have, that is from pin number 8 to pin number 13, I can connect to any of these pins. But this is the ground for the negative, positive and negative pins can be connected to ground, and positive pin is connected to the 8. I can connect to any of this. So if I change this pin number from 8 to 13, I have to make change to this pin number over here. I can make it as digital write 13, high, digital write 13, high, and the pin mode I have to configure it to 13 over here. So I have to configure the, so as I told, Arduino programs have two components. One is the setup part, which I set up the device based on where I need to get the input from, whether it's a digital input or output device, analog input or output device, whether I have a transmission and device that I have through this transmission modes, that communication device that I'm using, whether Bluetooth or any of the devices that I'm using, then I can use this pulse coded PCM mode, pulse with modulated signals, digital signals that I can have. If I have a normal digital signals, I can go for this digital data. That is 8 to 13 pins can be utilized. This is a simple program, and I have another sensor to work with that is called as ultrasonic sensor. So here, I think, I don't know whether you are able to see. Let me. So this is, I think you are able to see this sensor. If, oh, sorry, Arduino I have used. So this is, I don't know, all of you are able to see this sensor. If anyone can respond to me so that I can get clarity. So,
yes, sir, we can see
this
clear.
is a sensor, what we are using, the ultrasonic sensor. So this sensor has two components here. One is the left and right component. One component is an emitter, the other one is a receiver. So E and R. The other one is an emitter, and the other one is a receiver. Emitter sends the signals, the receiver receives the signals. So these components are okay. So I have the pins connected here. Again, this is a digital signal, analog signal that we are trying to connect. So the positive voltage, the ground, and one pin for the trigger, which is a transmitter. The other one is called as the echo, which is a receiver. So the trigger will send the, this is the trigger, the left part is the trigger, which will send the signals, and echo is the one which receives the signal. So pin number 1 will be VCC, that is the power supply. Pin number 2 has to be connected to the trigger pin, is an input pin. This pin has to be kept in high for 10 microseconds to initialize measurement of sending the ultrasonic wave signals. Similarly, echo is the one that will be output pin, that will, echo will send the signals and trigger will receive. Sorry, I was reverse, I told. Echo will transmit the signals and trigger will receive the signals. So this pin will be high for a particular period of time so that it will send the ultrasonic signals, and it has to get back the signals. So how this signals, the ultrasonic signals are transmitted, the other one will receive the signal. Now, we might have seen this particular set of sensors in our cars. On all the cars, we find these ultrasonic sensors. Now, how is it that these signals, when it is transmitted and received, how does it measure the distance? And once it is within a certain distance, it will give you a warning signal saying that some object is within the distance where you can collide with those objects. So how does it measure? So this is how the measurements goes. So the trigger will generate the 10 microsecond signals, and you have a sonic burst of signals will be continuously transmitted, and echo will be echo will generate the signals, it will receive the signals. So the echo, this will send the signals, and echo is receiving the signals. If there is an object, it goes and returns back. And there will be a microcontroller that I'm Arduino board that is connected here. The pulse signals will be generated. And for a 10, just a simple calculation that is done over here, for a 10 centimeter distance, the speed of sound is, if we consider the sound echoes, sound signals that are transmitted, and if we see the time equal to distance by speed, so we can calculate 10 divided by 0.34 to 0.94 microseconds. So based on this, the distance is calculated based on the sound wave that is communicated and returned. If it takes more time for receiving back, it indicates that there is no object within a space. We fixed the threshold. We fixed within this threshold, if you are able to receive the signal and the distance is measured as 10 centimeters, so I can have this speed and the travel or the speed of sound is measured like this. And based on the computation, if it's calculating and if your object is anything between 10 centimeters, it automatically senses that because it is receiving the signals at that particular pace, and automatically it gives a warning to the end users that there is some object over there. If you're not able to receive any signals, it will be continuously emitting the, as I told in Arduino, you have a continuous looping. As and when we start the engine of the car, this Arduino board starts working. It may be Arduino or Raspberry Pi or LoRa. We are using, we have n number of platforms at present. We can use any one of them in our devices. So as and when it starts emitting and it receives, the other one will receive the signal and constantly measures the distance. Every time, now and then it continuously measures the distance. If any time this Arduino board receives the signals which is within the 10 centimeters, if it measures, this Arduino board computes this value. If it is within that 10 centimeters range, it will generate an alert to the end user that some, it may be buzzer sound or it may be a display on the monitor or some sort of an alert is generated by using these ultrasonic sensors. So the next one that we have is the IR sensors, infrared ray sensors. So here in the sensor board, again, VCC will be the voltage, positive voltage, ground, and output. This is a digital data, hence the digital pins. It's not a pulse width modulated data. It's, you can have an infrared signal generated over here. So as I gave an example of this shopping malls, every time it generates, it continuously, the infrared signal will be generated. And as when person enters onto that infrared signal will be blocked, and thereby an intimation will be given to this Arduino board, then the counter will be incremented. So we can program this Arduino board in such a way, we can write a program wherever there is a voltage break, the signal break from this infrared, which is connected to pin number 2 or any of the digital pins. If the signal is not received to those digital pins, automatically the counter has to be increased every now and then whenever there is a break. When there is no break, you can automatically, the counter remains as it program the device. So you can connect the pins. As I told, there are 3 pins that we have for this IR sensors. That is so ground, VCC, ground, and the output pin. Output pin, we need to communicate to any of the digital pins. Similarly, we have another one that is called as air quality monitoring sensors. I think I have that with me at present. I'll show this air quality monitoring. We have used all these sensors here. Let me show this. So this is the air quality monitoring sensor that we have here. So this air quality monitoring sensor, it gives us the pH value, the air quality, what are the parameters that we have for air quality. We can sense that, and we can do the programming on this air quality monitoring. We have an application that we have designed for monitoring the air quality to see that how healthy environment it is. So we have designed, this is the air quality monitoring sensor that we use. So again, this has 4 pins that we can work upon. So we have 4 pins for this. The sensors, again, the ground, VCC and the ground, and one is the analog signal we are generating here. That is, so we connect it to an analog signal, analog input signal. That is any of A0 or any pin here, A0 to A5. Any of these pins can be connected for analog, because the air quality sensor generates analog signals. We are connecting it to the analog pins. Here in this case, we are connecting it to the digital pin because it generates a digital signal for us. It will be either 0 or 1. Whenever there is a cut in infrared, it will become 0. Whenever there is a continuous infrared signal, it will be 1. So we have digital signal here. So it will be 1 or 0 over here. It is air quality will be in the form of analog signal. So we are connecting it to the Arduino board using analog signals. So we have this moisture sensor. So let me show that moisture sensor that we have. So I don't know where I gone. So am I visible? I don't know. So somewhere my screen has gone. So here is the moisture sensor. We dip this particular 2 pins we have. This is the one which we connected to the Arduino board, and this is the pin which we dip it to the soil. And when we dip that into the soil and connect this to the Arduino board, it gives us various parameters with respect to the moisture sensing. It gives us moisture, what is measure. We have various aspects that we collect from that moisture sensor. And we can use that again sensor board. We have VCC, ground, and again we have A0. This is again analog signal that is generated. So again we will be using that analog signal A0, or any of the analog signals can be utilized for communicating. Similarly, we have another sensor, that is servo motor sensors. The servo motor sensor, when as we saw, we can have some activity being carried out. I'll show you one demonstration of the servo motor sensor. It will be rotating. So as and when an event occurs, the motor has to start rotating, like pumping of water from ground floor to the water tank. So all this, when we can have a particular this thing, we can use that. So servo motor, again, red wire is the VCC, black wire is the ground, and again green wire is the pin number, again digital data. Here the data for the motor will be in terms of digital data, where 1 represents that positive voltage and 0 represents the negative voltage. We can have programming where you can control those digital data, which will be converted into analog for this motor, and then it will be rotating either clockwise or anti-clockwise based on our requirements. Just like we have our car where window raising and window lowering, we can do that using these particular sensors, some of the applications we can use. So coming to the next part, that we have another sensor, that is a Bluetooth, the communication sensors. As I told, those are all the sensors which were fetching us the input, where you can fetch the data and all this. When I want to communicate, I need to have a Bluetooth sensor. Sorry, I could not get that with me. So there's a Bluetooth sensor which we can use. There's again transmission and transmission. So I was talking about TX and RX, receiving and transmitting and receiving the ground VCC, then the ground, and 3.3 volt power supply. This also Bluetooth sensor requires power supply for this. So we are connecting for the device power supply. From this Arduino device, we are giving the power supply to this Bluetooth communication device. So this acts as a communication mode, the data communication and everything. This will act as a power supply mode, which we can utilize for transmitting the data for this particular device. So this is a Bluetooth sensor which we work on. So all this Bluetooth communication, receiving, everything can be controlled by one of the inbuilt app that we are using at present. That is Arduino Bluetooth terminal. So it gives us that is HC05 Bluetooth monitoring. I can monitor the air pressure, the temperature. I have connected some sensors. It's not only the Bluetooth sensor that is connected. I have connected temperature sensors, the air quality monitoring sensors, the humidity sensors, infrared sensors. All those are communicated. All these sensors are communicating to mobile device or any of our Bluetooth devices using this Bluetooth interface. Using the Bluetooth interface, it's communicating, and it's giving me all the data regarding the temperature, regarding the air pressure, regarding the humidity, the infrared sensors, and what is the name of those sensors, right? I'm using a temperature sensor here. I can give any, I can rename them as per my requirement. So I have all the sensors. What is the reading of each of these sensors that I'm working with? So it gives you, this app can be utilized. We use this application, Bluetooth inbuilt Arduino Bluetooth terminal application is available in the Google Play Store. We can use this, and whenever I want to know all these devices communicated and through my mobile device, I can use this application and see how this Bluetooth device is communicating all the data that is being fetched from all the sensors that I connected to this Arduino device. So the next I have ESP. This is a Wi-Fi device. And whenever I want to communicate to the cloud or any of the other environments outside, within the local environment, within, as I told, within 100 meters or 10 meters, I can go for Bluetooth. If I want to communicate to the cloud or any faraway distances, I need to have a Wi-Fi module. We have a ThinkSpeak Wi-Fi module that we have purchased over here. And this is a Wi-Fi model. I don't want to go in depth about this Wi-Fi model. And we are using a cloud environment to store all the data that I have fetched. That is called as the ESP ThinkSpeak. We have ESP ThinkSpeak, and this is a blinking application. That is a mobile application. Just I have given it as B. Any mobile application, just as I showed for the Bluetooth, I have a mobile applications which we can devise ourselves, or we can use the inbuilt applications already available. So this is where I can control, and this is where I get the inputs from. This is temperature and humidity, the gas and smoke sensors, the light sensors, light levels, and all those connected through Arduino device. And this is where the output will be generated. That is the bulb, fan, heater, room. So if let us assume that there is a temperature increase in temperature, then automatically I can switch on the fan. So how do I switch on the fan? I'll be storing all these temperature values and the humidity values will be stored onto the ThinkSpeak, and it will be measuring these values. That is, ThinkSpeak will store all the data, and it will be measuring those values for me, and it is stored onto the cloud, the temperature. So I fix a particular threshold. Immediately, as and when it goes beyond the threshold, it communicates to the application stating that it has gone through beyond the threshold. Through the application, I have a program in my application which will invoke this Arduino board and switch us on the fan for me. Similarly, if it goes darkness, light sensor I'm using, as a morning sir was telling about darkness, morning 6:30 I have to switch on the light, and evening 6:30 it has to be, sorry, evening it has to be switched on, morning it has to be switched off. Instead of that, I can have a light sensor. Any part of the time, day, if the light goes beyond goes below the little threshold that I have set, immediately the bulb switched on. If it goes above the threshold that I am setting with respect to this light sensor, it has to be switched off. So I can store on a regular day-to-day basis. I can store it on a cloud environment. I can see how many times the temperature has gone down, how many times the temperature has increased, how many times the air pressure has changed, then how many times the light meter has reduced, given less. So I can analyze these values and see what is the environment condition in the scenario that where I'm working with. So I can use those applications and see how the environments are best suited for my applications. I can make decisions based on the data set that I have in this cloud environment, and I can program my devices according to the requirements. So these are some of the things that I wanted to show you regarding these sensors. As I told, there are billions of sensors available in the market, and we in our lab have certain set of sensors which we are using for carrying out our certain projects at our lab. So let me go with the test cases. We come to the last part of our deliberation, that is some test cases that we have worked upon. I'd like to elaborate on those test cases. So one first case study that we have worked in our labs is the indoor air quality monitoring using indoor plants and machine learning. So what we have done is in our lab, we have kept some succulents. We have kept all those succulents, and they try to purify the air and see how the air quality will vary without the succulents and with the succulents. What is that air quality that goes through, and how the air quality can be monitored. Out, and using the machine learning algorithms, we try to analyze the quality of the air. So the intention of this particular project that we carried out, it was carried out by a few of our students to monitor the indoor air quality level in the presence and absence of the indoor plants. That is what I called about the succulents. Then to identify various indoor plants that can be remedy for the various health issues due to poor air quality. So if a particular succulent is able to purify the air in a particular environment, and we can suggest that this particular succulent will give a measure by analyzing the data quality of the air that is generated in that environment, we can say that this particular succulent is good at purifying the air. Anywhere if there is an air pollution, air quality is not good, if we can cultivate, we can have those air succulents at our environment, we can have a better air quality. We can just suggest that is one of the intentions, to make use of wireless sensor technology and connect different nodes to ensure the air quality is monitored. So we have used all those IoT devices, and to evaluate the benefits of deploying these smart devices with indoor plants in a suitable indoor. We have deployed these plants and IoT devices in our lab, and we could monitor the air quality on a day-to-day basis, and we could analyze in the morning time how the air quality is varying, in the evening time how the air quality is varying. So we could try to analyze. So what is that we did for this project is that we could record. So all the data that we collected would be displayed onto the LCD devices also. I'll show you how it worked out. Then we had the readings to upload all these using the XAMPP server. We devised our cloud application using the HTML web application, PHP applications we designed. And to communicate, we had a ESP8266 Arduino board for interfacing. Then we had air quality measuring sensors. Then we had floating sensors. And I'll show why we use this floating sensors and all this. We had different sensors. And we stored all that into the server, that is what we call as a ThinkSpeak server, cloud server, cloud environment. Then taking all the data that we had, we applied certain machine learning algorithms The machine learning algorithm that we used was a decision tree algorithm here, where we could take all this data that we had collected and apply the decision tree algorithm in order to predict what was the quality of the air and whether it was fit for that environment, whether we can call it as a good quality. We fixed certain threshold beyond which we could call it as a poor quality, within which we could call it as a good quality air environment. And based on that, once we could see that there is a change in the quality of the air, we could send suggestions to the people who are involved in through emails and SMS. We could send them to those mails so that they can take a proper actions if at all required. And if a person is over there, can we enhance the air quality? If there is any fire over there which is creating the smoke, so that the air quality is being reduced, so we can take necessary actions. To take that action, we could whenever there is air quality getting below the threshold, the air quality was getting poor, we were enabling to send the message or a mail to that concerned set of people who are monitoring the air quality. That is what we did in this particular project. So what are the things that we did? The algorithm, like we could collect the sensor data. As I told, three sensors that we have, MQ135, that is air pollution control, air quality monitoring, DH11. Then we had a float sensor to see the water level. We are pouring water to that particular setup that we had done to maintain the temperature. So if water level goes down, the automatically temperature is to reduce, which would indicate us that the water level is less. So we have to put the water over there. So we could check, is the water container empty? If trigger the buzzer, it used to trigger buzzer that the water level is less. So we used to go and put the water again. If it is within the range, it will display the sensors over here, all the sensor data like fan rotation, how DH11 is a rotation sensor. So it gives us a fan rotation. Have that through the PHP and the XAMPP server. We used to communicate that into the ThinkSpeak cloud, and we used to store the data. Use all these data from this ThinkSpeak cloud, apply the decision tree. As I told, we use decision tree machine learning algorithm here to predict the air quality for a particular time duration. We took it for 1 week. We used to monitor it for 1 week and how the air quality was changing. If the air quality is good, it continuously goes through. If air quality is poor within the below the threshold, we used to trigger a mail suggesting that mail to the end user or the concerned people how the action can be taken, what has to be done, what precautionary measures has to be taken, so that we can take those precautionary measures so that the air quality can be improved. So this is what we did. This is the setup that we had. So these are the second that we have set up. This is the monitor where we used to get the air quality. This is one of the sensors that we have. This is air pollution monitoring sensor. This is the interface that we are using. So this is for the water level that we go through. So this gives us the environment where the water, what is the level of the water. This was a fan. We used to pour water here and it used to be communicated. And when the fan was rotating, the temperature used to be very cool. Once the water level decreases, automatically the temperature used to reduce. So, and this air pollution, this sensor used to check us what is the quality of the air, and all these data used to be communicated through this Bluetooth communication device. Sorry, we had a Wi-Fi communication device which was set up in this model, and we used to get the mails. So these are the coding part of it. So as I told, it will have, I'm not projected on the setup part of it. I just concentrated on the loop part of it. As I told, loop is nothing but which will be continuously repeating. So whatever the aspects that I showed in the flowchart, like humidity, it reads the DHT, read humidity, read temperature, and gas data we used to get from the gas, that is A0, that is analog signal that we used to get. Then we used to have this gas sensor data, the ppm value that you used to get. So continuously we had this digital data that like for float sensors. So all these data we had, and we wanted to display it onto the LED monitor, that LED screen that we had. So these are the aspects like print air quality value that we read, the ppm values, then the cursor location at some other, the temperature, the degrees, all these are for the displaying onto the monitor. Similarly, the ppm values, we had set the threshold, good air quality. If this goes beyond greater than 50 and ppm value is less than 100, we used to give average quality of the air quality. Similarly, we had a condition for the bad quality and the poor quality. So all these are the programming part as far as sensor data is concerned. This was the PHP program in order to connect your data onto the ThinkSpeak server. All this data that was taken, it was to be communicated through the serial print line communication, and it was stored onto the ThinkSpeak cloud. And based on the requirement, we used to send the data to the respective mails, right? So if there is nothing to be communicated, the connection used to be closed. If anything to be communicated, we used to have this local host server that we have one. And this is our college IP address. Through this IP address, it used to be communicating to the respective end users. We had our own students and the guide and all those. We used to communicate the data so that we can take actions for that particular values. So the display of the air quality was displayed using graphs at the mobile end, displaying in terms of graphs, air quality in terms of green, then the temperature, then the humidity, all these values. This is the data that is projected for 1 week over here. So for 15 days, data is projected over here. Based on, we could understand how the air quality is changing on based on a particular. It is maybe during winter, we could try to analyze this data. During summer, how does it change? During rainy season, how this air quality changes. If we could monitor this and see what are the variations in the air quality, because we are at an industrial area, our college is set up at an industrial area, we could monitor this air quality during morning when the companies are closed, and during the evening when they are at a peak for working hours. We could monitor all this data and try to analyze which is the best time where we need to monitor all these parameters so that we can take certain actions over here. This was one of the applications that was done by our students under my guidance to take care of all this data. So let me give a video demo for this. And so I don't know whether you are you able to see listen to the audio? If you can let me know.
Yes, sir.
So it is self-descriptive. It will be.
Yes, sir, clear.
Increase the volume.
So if you are able to listen to the audio and read this, it is self-explanatory.
Yes, sir, clear.
Okay, fine.
Video చూడమ్మా. Plants are arranged in 3x3 matrix.
Dr. Guru, sir, you can explain in between.
So this particular project demonstrated about the different aspects of the different sensors that we used. And this was selected for month-end project ideas, and we could participate over there. And we got good comments from the people over there and appreciation from the set of people. So we have another project here. I think the project. So the project is about a smart jacket that where we can have for a women's safety purpose. What is a smart jacket? So this was one of the projects that was carried out. So let me demonstrate.
Proposed design of our project, which is called as smart jacket. There are two major components. One is Raspberry Pi camera and a button which acts as a switch. The whole operation is independent of the user and it is dependent on the operation of the switch. On pressing the button, we get the display message on the terminal which is quoted as button pressed, following which Raspberry Pi camera gets activated and a red light glows which indicates that the camera is ready to capture the sequence of images. The captured images by the Raspberry Pi camera, that is in our instance, a sequence of 5 images is sent through a Gmail attachment to the intended recipient. We can give any number to be the emergency contacts of the user. We get a message stating that this is an emergency message from the registered phone number, which alerts the emergency contacts of the user.
So this is one of the projects carried out during this year, and this project was selected as one of the best project of the year by Karnataka Council for Science and Technology, which we participated and we got the best project award for the academic year. There's one more project that we come across, the automated fruit vending machine, which we designed this project for our annual day celebrations, where we set up this stall and the persons can go there and drop in the coin and get the fruit. Just like automatic chocolate vending machine, we designed this. So they can pay through PhonePe or any of the things, scan it, and they can get the fruits. So this was one of the projects which we demonstrated during our annual day. So there's one more like automated flower offering to Ganesha. This was for inauguration of some event. We wanted to do best use of the e-waste that we had. So we used that e-waste and tried to generate using the motor. We had a motor sensor, and using that, we generated a flower offering to Ganesha over there. So this is a tilted image. So this is a CPU box that we have, a motor set up here. At every particular point of time, every time duration, it used to rotate and offer the flowers to Ganesha over there. It was one of the model that we designed for one event in our department. This is another model that we have where students can log in and maintain their attendance. That is RFID based attendance system. So they have given RFIDs, and this is a RFID receiver. And as and when they log in, they just like as we have in the offices, they just tap the tags and they mark their attendance. Similarly, we have the tag here, and this Arduino board will collect the data and mark the attendance for the particular student. This was one of the projects that we did as a hobby project. So these are some of the projects that we have carried out by our students during this academic year using LoRa, using Raspberry Pi and Arduino. So first one is NADI Nizen using IoT and machine learning. It was a project where we could have IoT sensors on our hand, and we could measure the pulse rate. Based on the pulse rate, we could store the data of the pulse rate, and just like as we have the watches, health bands now, we designed our own health band, and we could collect those and store it into a ThinkSpeak cloud, and we try to analyze the health of the person, and we could give some suggestions to those people. Then one more we had, that is IoT-based smart monitoring of psychological stress through the succulent plant, just as I demonstrated one. The other one is design of development of a sensor-based jacket for women's safety. Just I demonstrated that to you. The other one we have is automatic fish feeding and water quality management. Here we have the fish tank, and based on that, if the food is empty, it gives us a buzzer, and automatically we have a bowl over there, and the bowl will be fed with the food. Once it is empty over there, it will be tilted, and food will be put onto this fish ponds, so that fish will not be striving for the food. We have some threshold set for that, within that it will be depositing the food to the pond over there. That is one we had. And digital payment based vending machine, just as I told, full fruit vending machine. Then voice based assistant for our institute. As and when temperature goes to a certain level, it used to generate a voice based assistant that the temperature is so and so. As we have in our cities, giving us pH values and all those, some notice boards will be there on the traffic. Similarly, we had in our college campus, where if the temperature goes below certain threshold, it used to announce the temperature is so and so at this point of time. Every 1 hour, 2 hours, it used to announce. We had just a hobby project that was designed. Then we have a smart library based application. Then TensorFlow based object recognition. This was done for a robotic lab. Here we have a robotic lab in our institute along with the IoT lab that we have. So we coordinated with each other and we could make a robot to move around and identify the objects using this ultrasonic sensors and some TensorFlow algorithms. We went through that. So these are some of the applications, and thank you for your patience listening. And thank you to the organizing committee, the management of Srinivasa Institute of Technology and Management, and my guide, Dr. Tipenswamy sir, for providing this opportunity to deliberate some things.
Some queries will be there, sir.
Yeah. Hello.
Some participants wants to ask some queries.
Yeah, sir. Sure, sir.
So please wait for some minutes.
Yeah, sure.
And
sir.
ask the participants, please ask any queries and doubts if you have.
Sir, one doubt, sir.
Yes, sir.
Sir, Raspberry Pi microcontroller it may be using. The codings are same or different, sir?
The coding environment is different over there. But we use in both the cases we are using Python only. But in Arduino we use Arduino inbuilt tools. We have inbuilt code over there. We'll use that. But when it comes to Raspberry Pi, we have to do the programming using either I told some programming languages there. When we want to program the end devices, we use some languages are best suited. When we want to have a communication device, we have some languages. When we want to go for a cloud-based programming, we have different applications. So Raspberry needs to do, but Arduino has an inbuilt editor and all the prototypes we have over there, we can use those prototypes.
Actually, what is the difference, sir?
The difference is we have to use a specific programming language for Raspberry Pi. We have to use either Python or Java or any of the coding language. But here we have either we can use C or C++ in case of Arduino. It is well suited. There is no specific language for any of these tools. Based on what environment we are trying to code, we can use any of the languages. We use C++ and Python in all the cases, in Raspberry Pi as well as Arduino.
Thank you, sir.
Okay, thank you.
Is Raspberry, sir, industrial version?
We have a demo version over here. We have a trial. We have purchased. We have a tie-up with certain companies. We are using Raspberry Pi versions. We have a Karnataka State VGST sponsored lab at our campus. We are using that particular thing.
Yeah. Thank you, sir.
It is sponsored by Government of Karnataka for us.
Okay, sir. Thank you.
Any more questions? If you can answer.
Any more questions, please raise. Any more questions, please?
Hello?
I think, yes, sir.
Can this air quality control system can be maintained within the campus?
Sir, it's a prototype that we have done as of now. We have to have a product oriented. That is where we competed in one of the month-end competition for a business implementation and sponsorship. But for to certain reasons, we could not get the sponsorship. We are still trying for the sponsorship to establish a product out of this. We are not. We have a prototype version of it as of now.
Okay. Very good, sir. Thank you.
Any more participants? I request all the participants to fill the feedback link, which has been shared in the Zoom chat box. I request carefully you fill the feedback form. I'll hold the just 30 seconds, 1 minute for in the chat box itself. So thanks all the participants for attending this wonderful program. So I thank especially to Dr. Honorable Resource Person here, Dr. Gurraj, as well as Dr. K. Tippeswamy. So from Vishweshwaraya Technological University, both the professors are excellently morning session and afternoon session. They have given and shared the topics. Once again, I welcome thanks to all the organizers for arranging excellent programming for this event. So I request all the participants fill the feedback form once again. I mean, so if those who are not filled, just I will hold the 30 seconds. So remaining, I think.
Sir?
Yes, sir.
Can I say something?
Yeah. Tell me, sir.
Yes, sir. I would like to extend my thanks to my student, Dr. Gurraj KS. He has excellently presented the demonstration of IoT and case studies. And I congratulate Dr. Gurraj, sir.
Thank you, sir. Thanks a lot for the support and the opportunity provided to me. Thank you, Swami sir, and the organizers of Srinivasa Institute of Technology Management and the event organizers. Thank you all of you for the wonderful opportunity given to me.
I want to extend my thanks to the SITAMS college organizers who are given an opportunity to demonstrate our works, what we have done for our research work. This is the platform where we have demonstrated our work very nicely. And once again, I thank all the organizers for providing an opportunity and the platform. And special thanks to Dr. Pawan sir. He's the key person who have fetched the project from the AICTE and given an opportunity to everyone. Thank you very much, sir. Keep going with this kind of programs in future also, sir.
Thank you very much, sir. Thank you, sir.
Thank you, sir. And I thank all the participants for patient listening of our morning and evening session. Thank you, all the participants. Finally, I thank our university authorities for providing an opportunity to attend this and demonstrate this work in this beautiful occasion. Thank you, one and all, once again.
Thank you, all of you, sir. We are closing the session.
Yes, sir.
Thank you, sir. Thanks a lot, sir. Thank you, sir.